Hi, and welcome to day 3 of multiplying and dividing rational expressions. So, first thing we are going to do is make a conjecture about the product x cubed over y to the 4th times y squared over x. What will it be? Explain your conjecture and give evidence that it is correct. Well, what do you think the answer would be? Well, I think that this is no different than rewriting it as one fraction. Because when I multiply, all I do is multiply numerators, multiply denominators. So I can cancel out the x with the x cubed and get x squared. I can cancel the y with the y squared and get y. So I'm left with x squared y over 4. So I need to give evidence that it's correct. Well, let's go back to what x cubed y squared looks like when we expand it and 4y and x. This looks like x, 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 y, y over 4x, y. So I know that this x can go with that x and this y can go with that y. And if I look at what I have left over, I have x squared and then y. Let's see here. Oops, yeah, over 4. So I get the same answer both ways. Okay, so moving on to example 1. It says find the following product. Product means we multiply. Well, if we multiply, I don't want to have to worry about doing a double distribution or a tabular method or any other kind of method to multiply those two fractions together, because that is very large and cumbersome and would make it very difficult to break it down. So just like we did up here in this problem here, I broke this problem down into its parts. So I'm going to do the same thing. I'm going to factor. So I'm going to factor here, and I will get 3 times x minus 2. And then the denominator is 2 times x plus 3. And then in this numerator, over here, there's a GCF of 5, and I'm left with x plus 3. And then in this denominator, I have a factor of 4 and an x plus 2. So I have an x plus 3 and an x plus 3 that cancels out. Nothing else appears to cancel out because the x minus 2 and the x plus 3 cannot. So if I multiply across, I will have a 3 and a 5 left over, which will give me 15, and an x minus 2. In the denominator, I have 2 times 4, which is 8, and an x plus 2. So that is my final answer. So this is summarize what you have learned so far with your neighbor. Well, I'm your neighbor tonight. So what I have learned is that 1, I must factor first. Before I multiply, I factor. And 2, I cancel factors. And remember, factors are in parentheses sometimes. They are not terms. I can only cancel factors. And then 3, I rewrite, and in the process, anything that's left over, I multiply. So I just bring what's left over at the end and I write it down. So let's try the next problem. Find the following product and reduce to lowest terms. Again, I need to factor before I do anything else. So in my first fraction, I can look at the numerator and I see I have a GCF of 2, so it's 2x plus 6 over Factors of 6 that subtract to give me 1 are 2 and 3. So I have x, 2, and 3. Oh, my bad. That's x plus 3. I don't remember if I said x plus 3 or x plus 6. I took out the 2, so that should be x plus 3. My larger number takes the sign in the middle because it's subtraction, so it's plus 3 minus 2. And then times, my numerator is a difference of two perfect squares, so it's x plus 2, x minus 2, all over 2x. Now when I'm looking at all of my factors, the ones I have in common are x plus 3, and an x plus 3, and x minus 2, and an x minus 2. And believe it or not, these 2's work. They are factors. So I'm just left with, for my final answer, x plus 2 over x. I can't go ahead and cross out those x's because if I cross out those x's, I become a homewrecker. Remember, math homes are happy homes. For number 3, this one is a little bit more challenging because we have a negative exponent. And I don't know if you remember what to do with a negative exponent, but with a negative exponent, you need to flip what's inside the fraction and then raise it to the power. So I need to rewrite this as 3m plus 6 over 4n minus 12, the quantity squared, times n squared minus 2n minus 3 all over m squared plus 4m plus 4. So now I'm going to actually try to do some factoring inside my parentheses so it makes it easier to simplify. So inside my parentheses here I have a GCF of 3, so I have 3 and then m plus 2. In my denominator I have a GCF of 4 and n minus 3. And then I need to take the whole thing and square it. I can factor this parenthesis to the numerator to n minus 3 and n plus 1. And in my denominator, I can factor that to m plus 2 and another m plus 2. Before I can multiply, my order of operations said I have to take care of my exponents. Now that I have it factored, it's actually easier to square what's inside because I can square each of the terms. So 3 squared is 9, and then I have m plus 2, the quantity squared, so it's just write it twice time. M plus 2, m plus 2. In my denominator, 4 squared is 16, and then I have n minus 3 and n minus 3. And I'm going to multiply that by n minus 3, n plus 1 over m plus 2, m plus 2. So now looking at everything that will cancel out, I have an m plus 2 and an m plus 2, another m plus 2 and an m plus 2, an n minus 3 and one of my n minus 3. 9 and 16 don't have any common factors, so I can't reduce anything there, and n minus 3 and n plus 1 are not the same. But I group my remaining factors, and it's 9 times n plus 1 all over 16 times n minus 3. So that was a lot of work to get to our answer. All right, moving on. To the next page, we are dividing. And if you remember anything about division, you have to remember to do your state change flip. And it doesn't change when you're doing rational expressions. So if we were to write down some steps for those of you who like steps, the first thing you want to do is factor first. Then do your stay, change, flip. And these two can actually be done together. So it can be done together. And then we cancel and rewrite. So really, division is no different than multiplication, except we have to do the state change flip. So let's try this. My first fraction, I'm going to factor x plus 2, x minus 2. My denominator is 3x, and it doesn't change. My division changes to multiplication, and then I flip my fraction, 2x, and then x minus 2. Now, I treat it like a multiplication problem, and I start to cancel what my common factors are. So I have x minus 2, and an x minus 2, and then this x cancels with that x. So now I regroup my factors, and I have 2 times x plus 2 over 3. And that's it. Find the quotient and reduce to lowest terms. Well, we're going to do factoring and state change flipping all together. So in my first fraction, I'm going to factor my numerator, and my factors of 6 to add up to 5 are 2 and 3. So I'm going to say x minus 3 and x minus 2 over x plus 4. My division becomes multiplication, and then I flip. So I'm going to factor this one first. Factors of 4 that add up to 5 are 1 and 4, so x plus 1 and x plus 4 because all my signs are positive. Then I'm going to do this one last, and that's a difference of 2 perfect squares, so it's x plus 3, x minus 3. So my x minus 3's cancel, and my x plus 4's cancel, and nothing else cancels, so I have x minus 2, x plus 1 over x plus 3. I don't have to put that in parentheses if I don't want to, but some of you will continue to do that because that's how it was in the problem, and that is fine. All right. We have one last problem to do. And this is the craziest looking thing you've ever seen. This is a fraction over a fraction. So you have a fraction in the numerator and a fraction in the denominator. This is what we call a complex fraction. And we're going to do a couple different things with complex fractions. And with this problem, the way it is written, because it's just simply one fraction over another fraction, we are going to use just state change flip. So my first fraction, my numerator, I can rewrite as x plus 2 over x squared minus 2x minus 3 times, or actually I can write divided by, just rewrite it as divided by first. X squared minus x minus 6 times x squared plus 6x plus 5. So essentially it is just one fraction divided by another fraction. So we're just going to do state change flip. So x plus 2, this factors to x minus 3, x plus 1, times this factors to x plus 5 and x plus 1. And my last part factors to x minus 3, x plus 2. So my x plus 1's cancel. My x plus 2's cancel. My x minus 3's do not cancel because they are both in the denominator. So I have x plus 5 over x minus 3 times x minus 3. Some people like to write it as x plus 5 over x minus 3 squared, and either answer is actually fine. But if you've noticed the whole time I was doing this, I only ever canceled factors that were in a numerator and in a denominator. I can never cancel two terms in a numerator together or two terms that are the same in the denominator. It's always a numerator and a denominator, a top and a bottom, never two tops, never two bottoms. I can do it in either fraction. They can be the same fraction or different fractions, but they must be a numerator and a denominator in order to be able to cancel. All right, that is it.